next speaker is Dr. Sarah Carpentier, and she answers this question: how do behavioral science and data science intersect to create more impactful solutions for organizations and people alike? In her talk, Big Data and BEE, Creating Bigger Impact Without the Risk, Dr. Carpentier will provide an overview on how data science and behavioral science complement one another and how they can come together for a more powerful organizational toolset. Today, data points are easier to capture than ever before. The challenge is going beyond measurement to change the patterns of the data and grounding the insights gleaned in scientific theories of human behavior. Behavioral science can help organizations ask the right questions and move the needle in a way that data science can't. Sarah has a PhD in cognitive neuroscience from the University of Toronto, the science of how the mind arises from the brain. Sarah's background in neuroscience and music preferences generated insight in how the complex interplay of the brain activity and environmental context influence our choices and behavior. Her thesis was selected by the Department of Psychology as one of the top dissertations in the country. She also spent years as a frontline distress and crisis line responder for both the Distress Centre of Toronto and the Canadian Suicide Prevention Services. She provided support to people who felt vulnerable and alone. Sarah's passionate about transforming society by applying relevant, data-driven insights and has worked on such BEworks projects as large-scale field experiments, AI, and the co-design of the BEworks Empathetic Communications Training Program for improving the effectiveness of interpersonal communications that is currently deployed within some of the largest organizations and call centers in Canada. Dr. Sarah Carpentier, it's over to you.
In Douglas Adams's novel, The Hitchhiker's Guide to the Galaxy, and bear with me, this is relevant, a highly intelligent alien species tasks a supercomputer named Deep Thought to calculate the answer to life, the universe, and everything. The computer spends 7.5 million years feeding all possible information into its computations and produces an answer: 42. Everyone is understandably disappointed and doesn't know what to do with that result. And Deep Thought responds, "Only when you know the question will you know what the answer means." Data scientists can be amazing supercomputers, but any pattern recognition without the proper understanding of why that pattern exists, what it means, what the question is really answering, and what to do about it is just as useful as finding the answer 42. We need to make sure we have the science part of data science. Thank you for joining me to talk about how we can shape a future with data science and behavioral science collaborating to efficiently and successfully uncover key insights and know what to do with those insights. In 2012, the Harvard Business Review published an article calling data science the sexiest job of the 21st century. And I will say I want the branding and PR team for data science to work for me, because no one ever said when I said I taught statistics, "Wow, she must be really cool." So we've all heard stories of great successes that applied statistics has had to solve business challenges and the very real ways that people are missing out by making decisions using intuition rather than evidence. And there's been a big increase in the willingness and the desire of organizations to capitalize on analytical tools that have become increasingly available, right? The demand for data science was up 50% in 2020. But with all this excitement and interest, we need to make sure that we're applying it right to get the return we actually need. Because over the past 10 years, there have also been enough people who took up that message of, great, I will use numbers and analytics to guide business strategy. And then after a few years, feel like maybe their big data strategy, the one they've implemented, is just really not living up to their expectations. They're not getting the impact that they're looking for from their approach. Some estimates suggest that around 80% of data science projects fail to achieve significant impact. So why is that? Most often, it's not a technical problem. It's not because these companies are not investing in fancy enough algorithms. Trust me, sometimes the problem is the opposite. It's because their analytics-oriented strategy pays a lot of attention to the data side and the math side, and not enough to the science side of data science. Right? All of the onus for a fully formed, ready-to-go solution is being put on bare numbers, usually ones that can be pulled from existing data the company already has. But human behavior is complicated. Understanding it, predicting it, and changing it is complicated. And organizations are clearly not getting enough of what they need to make a decision with a couple of data points. Right? In order for an isolated insight that a company uncovers about its customer behavior to be successfully put to use, It needs to be understood through the lens and the context of all that we already know about human behavior, right? A lot of strategies focus on building complex pattern recognition systems. But finding any pattern is not the same thing as properly understanding it and how it should fit into decision-making for the organization. We don't just want 42. We want to know what that means and what to do with it. To give a quick example of how behavioral science can fill in the gaps that are existing in a lot of data science strategies, we were involved with one company who was interested in having their salespeople function more efficiently and effectively. And as a part of their plan to find a solution and figure out how to better hone their team, they got their data team to build a predictive model of sales success, looking at which factors in their salespeople are correlated with successful sales. Their model was actually pretty good at predicting past sales. However, for all that investment, they actually didn't make something that was particularly useful for the overall business goal. That was because nothing in their model made good sense for an intervention point. Nothing that they said predicted sales was easily changeable. Things like tenure, geographic location, and a big one was sales the previous month. So these are not things that we actually have the power to change to help people do better. So we didn't actually learn very much that would help us build a strategy. A large reason for why their model was built this way is what's called the reactive analytics approach. An organization has a challenge, and they expect that the insights, the answer they need exists in the current data they already have on file, and they ask for very quick turnaround time on those insights. So the team put into the model what was the most accessible, but not really the most useful. With the data they had, they could get an answer, but this was not the one they really needed. So we pulled from what science already knows about human behavior relating to sales and used that to inform what should go into a new, more strategic model, right? Both from existing data they had and from new data to be collected, in order to have a model that can actually be actionable for behavior change. The output of that new model now clearly indicated behaviors that could be targeted for improvement. And then BEworks worked to develop strategies for behavior change to nudge people towards those behaviors. And then we designed experiments to test which of those behavior change strategies would be the most effective and should be scaled to field. This is one of the ways behavioral science and data science collaborate to move the needle. There's a saying, garbage in, garbage out. It doesn't matter how fancy your machine learning tools are. If what you're putting into them isn't right in the first place, then what you're going to get out of them won't be right. Data teams know this. This is why they are frequently the ones who point to us to point them in the right direction for what should be the right data to put in, so that it doesn't take them 7.5 million years, and to help them understand how to interpret what comes out. Because when a pattern is found, right, you need to know what it means and what to do with it. When behavioral scientists are faced with a question, we start by reaching into the past century of human behavior research. Right? Let's leverage what knowledge already exists, rather than wasting resources trying to relearn something. Then we design creative, targeted strategies and experiments to get the specific new data we need for what still needs to be uncovered. By following this theory and hypothesis-driven approach, when we get the output from the analytics, now the project is best positioned to interpret those results properly to influence the best course of action. Right? This is how to elevate impact from data science alone. When we get 42, now we know what it means and we know what we should do about it. So to recap a little bit, right? Behavioral scientists guide the team, the data teams of analysts, experts in AI and machine learning on what data should be considered valid input for their models and including how to get that data when we don't have it already. We understand the real-world full context implications of those data patterns. We create behavior change interventions, and we learn cause and effect through experimentation. In the last minute I have, what do I mean by cause and effect? Well, let's examine that through a quick example. Say your company offers 4 different products, And your data team tells you that when faced with choice between these 4 products, consumers by far and away choose one over the other 3. What decision should you make? Should you eliminate the other 3 options? The science of human behavior will tell you that making that assumption is a very large risk and you don't have the data to support it. Right? Experiments have already repeatedly shown that human preferences are influenced by the other choices that were available at the time. Behavioral scientists develop informed hypotheses, design data strategies, and creative experiments to learn about cause and effect. So now we can answer the question, what will happen if I remove the other 3 choices? Or the question, how should I most effectively encourage customers to choose one of the other options instead? These questions call for small, lower risk experiments, sometimes ones we call randomized control trials, that determine cause and effect before taking an idea full scale to field. So we don't have a lot of time today. We could enjoy talking more about experiments and randomized control trials on a different day. So as we're getting to the end here, what I've been thinking about is not leveraging the robust theories and insights about human behavior that have been developed over decades and how to conduct human research, and not conducting proper testing of strategies in low-risk environments is, at best, preventing organizations from propelling forward. And even worse, it's sometimes causing very real and very high-profile problems. An approach of the numbers are all we need is how we get sales models that aren't actionable, biased hiring algorithms, biased credit card limits, and music recommendations that suggest Coldplay to everyone. We don't need to be making these mistakes. We don't need to be trying to relearn insights that behavioral science already knows. Right? So data science on the one hand has a mastery in pattern recognition, statistics, and computer science. And then we have behavioral science on the other hand with the deep expertise of human behavior and social interactions and the creative experimentation techniques for finding targeted answers and uncovering cause and effect. By partnering data with behavioral science, we can be more targeted and accurate about guiding our analytics experts to know where to look and what the right answer is when they find it. We can understand the meanings of patterns when we find them. We can work simultaneously to develop behavior change strategies, and we can learn about cause and effect of intervening for change in a low-risk environment. Otherwise, all you've got is 42. Thank you for your time.